Okay, so today we're going to work on percents. And so this is how I want us to get started. So let me know if you have questions along the way, but for the moment, I want to start like this. So if somebody said 5%, 5%, you may remember the word per from the last chapter, where we would go miles per hour and things like that, cost per pound, that kind of thing. The word per still means the same thing. It means divide. And so this translation of words into math literally translates 5 per divided by cent 100. So there's two ways we will work these problems. One way is the fraction way, and one way is the decimal way. So the fraction way, 5 divided by 100, would look like that. So 5 over 100, the fraction way. The decimal way, 5 divided by 100, you may remember that when you multiply or divide by 10, 100, 1,000, it's a decimal shift. So multiply, you would move the decimal to the right to make it bigger, but divide, you move the decimal to the left to make it smaller because you're dividing by 100. So here's what it looks like. Here's 5. Here's where the decimal is if you placed it. Dividing by 100 goes 1, 2 to the left. So the decimal is 0.05. And of course, there's that front 0 that we do. But the key thing is 0.05. That's the thing. So when you're going to actually do a problem, 5%, maybe you'll do it as a fraction. Maybe you'll do it as a decimal. Since most of the time we get past this course where you're using a calculator, you'd probably do it as a decimal. Now, the very first, any question about that? So it's always dividing by 100, as if there were 100 people and we selected out 5 of them. You can visualize that, how much that would be. Now, one of the things that they do at the very beginning is, can you easily go from a fraction to a decimal to a percent? And so somewhere in this first section, fraction, decimal, percent, I'll just put it like that, they're going to have you play back and forth. Can you do a fraction to a decimal? Can you do a percent to a decimal or whatever? And so it's always, can you go back and forth with a particular number? So I'm going to start with something that's fairly common. If I had 25%, if I had to fill this chart in, 25% dividing by 100, here's the decimal right here, 1, 2, so it would be 0.25 is the decimal. Now, what's the fraction? Well, again, you can do it from here or here in this particular case, because it's not so bad. The fraction would be 25 divided by 100%. Okay. Now, the problem with fractions is that, the problem with fractions, not everybody's crazy about them. This fraction should be reduced. And so this is an easy enough job. Think of it as money. 25 into 25 is 1, and into 100 is 4. So with fractions, we're always looking for that simplest fraction, reduced fraction, and so on. The decimal didn't need it. So let's start let's start in a different direction. And so sometimes they'll just ask you to go from here to here. But I think it helps to see the big picture when all three. And so you can literally go from here to there. Notice that when the way this chart is set up, when you have a fraction, like 1/4, 1/4, it may work out to be a decimal first and then a percent. You know how the saying, you can't get from here to there. And so sometimes you need to go from a fraction to a decimal to a percent. In other words, follow that sequence. You can't always hop from one to the other. Let me do a different one. Here's 1/5. Now the decimal may be obvious to you and it may not. So let's say it's not. So this is going back to something we've done in the past. If you had a fraction 1/5 and you needed to take it into a decimal, this is 1 divided by 5. So literally, depending, this is not such a bad problem, but depending on the problem, you would have to divide it out. Now, people want to put the 1 here, but that's not right. And so literally, I think I've shown this a couple of times. With a fraction, you can turn it into a division problem, and then the 1 drops down. And so literally that places the 5 on the outside and the 1 on the inside. So this would be 5 into 1. Well, 5 doesn't go into 1, so maybe it would help to add a 0 or 2, I don't know. We'll find out. This divisor, this number 5, doesn't have a decimal in it. It's assumed to be here, so there's no need to shift the decimals in division. So all you need to do is take this and bring it up. And so now the problem becomes 5 divided into 10, which is 2. 2 times 5 is 10. When you get a 0 remainder, you're basically done. And so this decimal would be 0.2 if you throw in that front 0, okay? So back to our problem. So this is how we got there. We divided this out like that. This is the easiest job from here to here, usually. The fractions are more trouble, but this going from here to here, back and forth, is easy. So notice when we had percent, we were dividing by 100, and so the decimal moved from here to here. When we do the reverse, we do the opposite. And so the opposite would be to take the decimal and move it 2 to the right. So this is what I'm talking about. 1, 2. Now notice there's a placeholder here, and so I'm going to have to add a 0. So this is 20%. Okay. So this 0 could have been left here. I didn't, but I went 1, 2, and it's now 20%. Okay. Let's try another one. Let me think. 1/8, starting this way. So back to 1/8. 1/8. The 1 goes here. So it's 8 into 1, and I'm going to add a couple zeros. There's no decimal shift because this is a whole number. This comes up. So I'm talking 8 into 10 is 1. 1 times 8 is 8. It's going to take one more step. 8 into 20 is 2. 2 times 8 is 16. Subtract, and I have 4. And I'm going to add one more 0. Now, you know that adding zeros don't always work out, but I was thinking ahead. And so this 0 comes down. Finally, 8 into 40 is 5. 5 times 8 is 40. That's done. So 1/8 as a decimal is 0.125. Okay, so I did the work on the side. Now, this from here to here, going this direction, literally that way to the right, the decimal goes to the right. And so 1, 2 becomes 12.5%. So literally the way this chart was designed, when you're going from here to here, you have a decimal, you're going into a percent, you literally take it 2 places to the right. This is to the right. When you're going here and going backwards, from there to there, the decimal goes 2 places to the left. So the position of the titles actually helps. So you're going here to the right, you're going back to the left. And it's always 2 places because we're into percent, 2 places. How's that? Now, it turns out there's a couple of weird ones. And the 2 weird ones are actually worth noting. If I started with a fraction 1/3 and I had to make it a decimal, okay? I'm going to scribble on this page. So this becomes 3 into 1. And this is a case where things keep repeating, but let's just get started. 3 into 10 is 3. 3 times 3 is 9. 1 left over. Oh my, another 0. 3 into 10 is 3. Okay, same. It doesn't take long to see what's going to happen. 3 into 10 is 3. And this is going to keep repeating, right? So the decimal, let's see how they write it in the book. As a decimal, you're never going to write the whole thing. But we do have this little cute option of showing the repeating bar. It's 3 forever. And so that's what the decimal would look like. And so that would be an acceptable answer. Now, notice when we go to the percent, it might be easier to work from here. We have to go 1, 2 to the right. So that would be 33.3%. Many times this is written as 33 1/3%. Okay. So this was one way to say it. Depends on how they want it. If they wanted it rounded, you're throwing away part of the answer because the 3 keeps going and going. But then you see what happened. This became 33 1/3%. And so the other one that happens that's worth remembering, and I think it's easy enough to remember, is 2/3. When you divide it out, it comes out this 6, 6 forever. And so it comes out like that. And so you divide it out. So what you get is 66.6 repeating bar percent, or 66 2/3%. Now, in many cases, when you're working with decimals, it's almost easier to use decimals But in these two problems, it's almost easier to use fractions rather, because 1/3 is so much easier to work with than a repeating decimal. And so, although generally we like decimals because of their ease with calculators, in this case, you might be happier with 1/3 or 2/3 with these strange little problems. And so I'm just reminding you of those two particular problems. Now, let me see what kind of, let's see. So this is 6.1. And let's see. So what they're going to do, here's an example of one problem they might do. Change the percent to a fraction. Okay. So let's see what we have. We have 34.2%. Now that's a percent as a decimal. So here's a percent column. Here's the decimal column. And so to get from here to here, it's 2 places to the left. So this decimal point would go 12.342. I'm going to leave the 0 off for the moment. If I made it a fraction, it's actually easier to go from here to there. This is 342 thousandths. 3, 4, 2 divided by 1,000. Okay. What's the problem? The problem is we got from here to here with 2 decimal places to the left. We then would read this as 342 thousandths, which is this. Then this, because it's a fraction, needs to be reduced. Now they're both even. And so because of that, I'm going to divide both of them by 2 and see what happens. 2 into 3 is 1, 1 left over. 2 into 14 is 7, and 2 into 2 is 1. 2 into 1,000 is 500. The question becomes, is this totally reduced? Anybody see anything that might go into it? Obviously, with 500, it's probably a 5, but there's no 5 here. A 2, because this is even, but that's not even. What do you think? Do you think that's done?
Yes, because the 71 is an even number.
Yes, this actually divides by 3, but unfortunately this doesn't. I wanted you to never forget this lovely rule. 1 and 7 is 8 and 1 is 9, which means this one would divide by 3, even though it's hard to tell, but this one won't. And so 3 is out, 2 is out, 5 is out. I think we're done. Okay. So let's, but what if the problem started out 66 2/3%? Now, these are the only ones that look totally weird, but I think you could recognize it because this is giving you that clue that you need. So the decimal is, the 6s that keep going. And so it's that 6s forever. But the fraction, I think, instead of doing all these computations, just learn these two about 33 1/3 and 66 2/3. I think that's, they used to make people memorize all kinds of these, But I think these two, especially 33 1/3 and 66 2/3 are, if you see it enough times, you'll say, oh yeah, I've seen that one before. Okay. Let's try a different problem and then we'll move. Let's see. This one is the fraction. We want to turn it into the percent. And many times we will go on this road, turn this into a decimal, and then it's easy to just shift the decimal into a percent. So if that was the problem, we know what we need to do. There is a shortcut here, but I'm going to show you the way to do it for sure. 7 divided by 50 is 50 into 7. So the 50 is on the outside. You're going to have to put in some zeros here and bring this up. 50 into 70 is 1. 20 left over. Bring down that 0. Oh, this worked out okay. 50 into 200 is 4. 4 times 50 is 200. When we end up with a 0, we're done. So this is 0.14. I can throw that in just to show you I can do it. Then the original job was to get from here to there. I did it through the decimal. Remember, this is going, the decimal has to go to the right because we're going to the right, and this is 2 to the right, 1, 2, 14%. Now, I said there was a shortcut, and once in a while you see it, and there's no problem if you use a legitimate shortcut. And here's what it is in case you're interested. This is 7/50. If this 7/50 can easily be converted into 100, and this is going back to your fractions, if it can, we are in business. And so what we would do is to get 50 to 100, we'd multiply by 2/2. So 50 times 2 is 100. 14. 7 times 2 is 14. Once we realize that 7/50 is the same as 14/100, we now have the percent. 14/100 is 14%. But this doesn't always work. The divisor, this number here, might not go neatly into 100. And so if that's the case, you really need to go from the fraction to the decimal to the percent. Okay, you will get better at this as you go on. And so we're just using, and once in a while, they'll say, okay, get your decimal, but round it. And so if that's the case, we can do that. Now, I'm going to go to this next section, 6.2. They call it basic percent problems. And it really is pretty, the simple version, it's not really a word problem. And so they used to teach it several different ways. This probably, I'll show you the 2 best ways, I think. Here's one. What is 20% of 80? Okay. So it's a percent problem. You see the word of between 2 numbers. And if you remember, the word of between 2 numbers means multiply. So this is a skill, this is a translation problem, or this could be. The word what is X or N, I don't care which letter you use. The word is equal. Now, 20% of 80, I could rewrite this. But the truth of the matter is, what I have to do is turn this into a working number. And the percent number to multiply 20 by 80 will not give me the right answer. It's not 20, it's 20%. And so literally, we need to convert this either to the fraction or to the decimal. I'm going to try the decimal this time. So remember, when it was a percent to a decimal, the decimal shifts this way. So here it is, 1, 2, 0.20. The word of is multiply. And so I'm going to multiply this by this. So let me just do it on the side. 80 times 0.20. This is 0. This is 0. This is 16. The decimal shift because of this multiplication is 1, 2, 1, 2. So what I'm seeing is the number 16. There's no need to put the 2 zeros at the end. Okay. If I had used a fraction, it would be 20 over 100 multiplied by 80. So if I did my percent as a fraction, it's 20 over 100 times 80 over 1. I would still get the same answer. I'm going to reduce 20 over 100, or I can reduce this way. I can take out a pair of zeros for that. And 2 over 10 is 1 over 5. 2 goes into 2 once, 2 goes into 10 5 times. So this ends up being 1/5 times 80 over 1. 5 goes into 80. And if you do it, 5 into 80, it's 1. 5 into 30 is 6. One times 16 is 16. So it looked to me in this particular case, and you don't want to have to do every problem 2 different ways to see which one was better. In this particular case, it looked like it was a little bit faster on with the decimal, but it was totally doable with the fraction. This approach is translation. And so I'm going to do a different problem. And then we'll show what, say, 12 is what percent of 48? This is where people got in trouble, because they kind of knew that they had to do some sort of division or multiplication or something. And then the question was, do you multiply or do you divide, and which number is on top and which number is on the bottom, and so on. And so this became the problem. One solution is to just translate this basic problem into an equation. So it is 12 is equal. What percent I'm going to call X of is times, and 48 is 48. Exact translation word for word for math, as it turns out. We now know what to do when we have a little equation where the X is multiplied to a number. We learned that last chapter. So what you do is you divide this side by 48, and you better come over here and do the exact same thing on the other side. This reduces. 48 over 48 is 1. X equals. Now this, remember, we wanted a percent. So first of all, this is a fraction. It needs to be a percent. Well, the first thing I notice is this could be reduced. 12 over 48 divides actually by 12. You could do it in 2 steps. In other words, 12 times 4 is 48. So 12 goes into 12 once, 12 goes into 48 4 times. I now have a reduced fraction, but I don't have the percent. Now, you may recall some of these things are so common that 1/4 turns in very nicely into 25%. So remember, here's the deal. 1/4, the 4 goes here. Or maybe you know that this is 1/4 of a dollar, and 1/4 of a dollar is 25 cents. And so maybe that's clicking here. 4 into 10 is 2. 2 times 4 is 8. Subtract and bring down. 4 into 20 is 5. So what we have is 0.25. What we need is a percent. And so the percent, 25%. So we, in these problems, we have to sometimes take a fraction, turn it into a decimal, and turn it into, in other words, turn it into what they wanted. They wanted 25%. They wanted the percent, so we had to do it. Question, anybody? Okay, so the real problem started out with, could you make this no more words into math? And the math was this. We knew how to cancel the 48 on both sides. The rest of it was just going from the fraction to the decimal to the percent. Let me see if I can find a different one.
You're gonna do that with another set, same thing?
Yes, I'm going to do
Okay.
one more, and then we'll try to, 20 is 15% of what number? Okay. This is a basic problem. It's not a word problem. We're going to translate it into something we can do. 20 is 20. Is equal. 15%, I think I'm going to go with the decimal. So 15%, the percent comes off, the decimal goes back 2, so it's 0.15. The word of is multiply, and the what number is times x. This is a skill that will take you into the next course. 20 is 20, is equal, 15% has to be converted to an actual number that's usable. Of was multiply, and what number. The skill we have about solving for x is now used. I'm going to divide this side by 0.15 and divide this side by 0.15. Okay. The whole problem becomes, can I turn this into a number? Okay. So I've got an answer. I just don't have it in simplest form. And so let's see what we have. If this particular problem was 20 divided by 0.15, the 0.15 would be here. This is the case where we have to slide the decimal to make a whole number. And so this comes over 2 to the right. This would then have to do the same, 1, 2 to the right. And then I'm going to bring it up. Let's see what happens when I start dividing. I have no idea how this could turn out. 15 into 20 is 1. 1 times 15 is 15. Subtract 5. 15 into 50, 3. 3 times 15 is 45. Right?
Mhm.
Oh, I didn't mean this to turn out funny. This one here, bring down the 0, 15 and 50. See what's going to happen?
Repeat.
It's going to keep doing this, isn't it? Can you tell? 3 times 15 is 45. And so this would, keep doing it. 50. Okay, so it kept repeating 50, 45, subtract 5, 50, 45, and so on. That's how the answer turned out. Somehow I didn't get it. A lovely problem. This, strangely enough, this approach isn't bad. And so this is one of the approaches that they have. So let me go back. Let's look at this one, the first one. Oh, I'll just make it up. 12 is what percent of 48? There's another approach that may work just as well for you. And it was taught like this. One of these numbers is the part. One of these numbers is the total. And of course, one number is the percent, and the percent is easy enough to find. And so if you have the total is always after the word of. So it's of 48, 48. And so this would be 48. The total is on the bottom. The part is the other number, 12. And what we're after is a percent. Now, this is a proportion that we did before. And so you don't know the percent. But percents are always divided by 100. So the missing percent goes here. Let's look at this again, because this approach works as well. This, if they want the percent, it's here, it's X over 100. After the word of is always the total. And so it's 48 here, which means 12 has to go here. This then can be solved as a proportion. Remember the cross multiply? Now, because of this 12 over 48, I'm seeing that it could be reduced, and I would be really sorely tempted to reduce it now into 1/4. So that this problem becomes 1/4 equals X over 100. I just like smaller numbers, and I suspect you do too. As a proportion, this would be 1 times 100 is 100 equals 4 times X. In this particular problem, it's 4 times X. This is the skill we have. We divide both sides by 4. X equals 25. So right here is 25, which means our answer is 25%. Any comments or what do you think?
I like it.
You like that one?
Yeah.
Also, if somebody had been taught this way, this is their natural inclination. So let me see if I can find the other problem. I don't want that. Oh, here it is. Here was another one that I had done. So I want to give you another version of it. What is 20% of 80? So this was one of the problems I did the other way. This is done with a proportion. The percent over 100, the part over the total. And this,
Someone told me to multiply 20 by 80 and then divide by 100.
yeah, and so in some ways, it might be easier just to multiply these two because that's what you're supposed to do. But this can be done with the proportion way.
Okay.
20% would be 20 over 100. That was not a big deal. After the word of is the total, regardless of where they put it in the sentence. So the 80 goes on the bottom of this fraction. The part is what's missing. So this also will solve. This is x times 100, which I would write as 100x equals 80 times 20. Well, 8 times 2 is 16 with 2 additional zeros. And if I would divide by 100, divide by 100. X is 16. That was the answer we had before. These two are the methods that I think most people have the best luck with, either the proportion way or the translation way, which, you know, in this particular case, it's just a pure multiply. And so it makes sense just to multiply. But all the problems can be done with this approach too. And I can't really judge which problem is best. You might try it both ways. But we do have this skill of proportions. And so if you remember that after the word of, in every case with these basic problems, is the total. This is the total. And the total goes on the bottom. Then I think you can absolutely locate the percent, and it's always over 100. So this is a legitimate method. This is not the way they used to teach it. They used to teach it, there are 3 kinds of percent problems. In one type, you multiply, in the other type, you divide. And the third type, you divide, but people never knew divide what by what. And so they never got percents. They never got it. That's how I was taught, that crazy way. That doesn't work. This does. And I think this is consistent. This is also consistent where you're translating word for word for word. And it's a skill that's used. This is a skill that's usable. Both of them are skills that are usable. Okay. How's that? So this can be now solved. And so when we do an actual word problem, we will use one of these 2 methods. Anybody go far enough that they needed, let's see, needed help? 32 is what percent? No, is, sorry, 50% of what number? Okay. Does anybody want to suggest? I scribbled this. 32 is 50% of what number? Anybody want to suggest? Nobody wants to branch out. Maybe tell me which of the 2 approaches you would go with.
I would translate first, like the words.
Yeah. Okay, let's try the translation. So it's 32 is Is this a word?
Sorry, equal.
Equal, yeah.
Yeah.
50%, we need to make it something. I'm going to just make it a decimal.
Okay.
So
So 0.5.
0.5 or 0.50, right?
Right.
Of,
Equals.
there's
Or
no
sorry, no. So multiply.
multiply,
And then X.
X or N, whatever you like. I think translation works, but they both work. So now you've got X here, you've got this number here that needs to be ditched. We're going to ditch it. I have to divide both sides by 0.5. Divide by 0.5. Cancel, cancel. X equals. This has to be divided out. This is the number when you make it into a division problem that's on the outside. 0.5 into 32. Notice I don't bring in my 0 because I learned without it. And so I bring it in at the end. So this needs to be moved over one place. This needs to have the same thing, move over one place and then bring it up. So it's actually 5 into 320. You can rewrite it if it's too darn messy. 5 into 32 is 6. This is 30. 2 left over. Oh, good. 5 into 20.
4.
4. Done. X equals 64.
Mm.
Now you may have seen that. If this is half of my answer, right? 32 is 50%, half.
Yeah,
And what's our answer? Double.
you
64.
multiply
Does
by
that make
2.
sense that turned out?
Yeah, I can see it now.
I once had a student who I taught them percent. I love this story. I taught them percents, and they had done a lot of business with a lumber yard, doing home remodeling. And they were giving the person a discount of a certain percentage. After we went over this and she understood what was going on, she realized that they had done their calculations wrong. To their benefit, by the way. Can you imagine? Can you imagine that? I can imagine that. So she went in, explained how to do it properly. This was a long time ago, but still I like his story. And they said, we will fix all of your transactions. Just don't mention it. They didn't want, because they had done all the problems by hand and they had done them incorrectly. And so she got a nice discount. If you like it, this is useful. I think at one point I did so much, they thought so much work on my house in Maine, they thought I was a contractor. They gave me a discount like the contractors get. And I said, okay, thank you. But I had done that much work. The house was 1820 and it had to be, it was worked from head to toe, roof to the basement. And so, yeah, they gave me a discount.
Yeah, I used to work in a restaurant and we were like tipping to find out how much the percentage of tipping was.
Oh, okay, yeah, exactly. No, there's a lot of times where you're into this and you need to know the correct percentage. And at the very least, to recognize what is, what's reasonable. And you can spot errors. Somebody, let's see. Okay. Okay. All right. Let's go over that. All right. So I think no matter what the crazy problem is, you can do it one way or the other. And I want to take a little bit of time and start this section 6.3. These are applications of percent. And so let's see, let me find a good problem. Okay, here's one. If 48% of the students at a certain college are female, and there are 2,400 female students. Okay, all right. What is the total number of students? Okay, that's my question. So the total number has to be more than 2,400 because there's 24 female students. So, here's what you do if you try to visualize this. So here's 48% are female. And we also know that this represents 2,400 students that are female. The question is, what's the total number? Okay, let's try this. Let's try this approach this time. We want 48%, right? And this represents females, so don't forget that. We want the total number of students. Remember, the total number is here. Total number, even the word of is sitting there. Total number of students, the total goes here. So 2,400 actually goes, it's lined up. This is the proportion. This is female students. This is female students. This will now solve, and you're expecting something almost double this, aren't you? Like 4,800, maybe 5,000. Let's find out.
I got a total 3,552.
Okay, let's see. The other thing, we could reduce this if you wanted to, but let's just do this. Let's see how close we are. 2,400 times 100. So that's 24 times 1, which is 24, with what? 1, 2, 3, 4 zeros. 1, 2, 3, 4 zeros. Did you see what I did? 24 times 1 and then 4 zeros.
Wow.
Equals this way. 48 times x. Now what do you do? This is an equation. You want to solve for x. You need to divide. Okay? So this will be x, and this will be our answer. So this needs to be divided. If we did it this way, I hope it turns out sooner than later. 48 doesn't go into 240, but it does. Let's see, 48 times 5. 0, carry a 4. Oh, that's exactly right. 5 times 4 is 20, and 4 is 24. 5 times that. I knew it would be higher than 48, and so I just guessed that. Here's where the decimal is. I need to add the zeros to make this right. What's our answer? X is 5,000. Okay? Let's pretend you cared. Are you ready for this? You're supposed to smile. Do you care?
Yes.
We care, right? So if we care, we would say 48% of 5,000. How much is that? Well, that's easy to do. I'm going to go 5,000, my supposed answer, multiplied by 48%, which is 0.48. I'm going to go 8 times that would be 1, 2, 3 zeros, and then a 40. I'm now going to do the 4. 1, 2, 3 zeros, and now 5 times 4 is 20. I'm going to throw in all these stupid zeros. 1, 2. What's my answer? 2,400. 48% of 5,000 is 2,400, which is what the answer, the problem told us from the beginning.
Mm.
Now, I make a joke about, do you care about this answer? But let's say it's your money. Maybe you do care. Maybe it's your discount at the crazy store that's not quite getting the math right. Do you care? Yes, we do. I'd say we do. Okay. Let me see if I can find something else. Here's a problem. There's a shipment of parts, and they're saying they're airplane parts, but it doesn't really matter. 3% are defective. Okay, so it's a company that's making parts, and 3% are defective for whatever reason. If 15 parts are defective, how many parts in this shipment? Question mark. Can you visualize this? Let's visualize it. Here's a shipment. It's all in this container. A small percentage, 3%, these are the defective ones. So there's quite a bit of good parts over here, but 3% are defective and have to be, not used. So the question is, they want to know how many parts in the shipment. So in translation, it would be 3% is 15 parts of the total shipment. So this may and may not work, but let's follow it. 3% represents or is the 15 parts of the total shipment. This is the sentence that will do it for us. 3% is 0.03 is equals 15. The word of is times X.
Hmm.
Something went wrong. I said the sentence wrong. I definitely said the sentence wrong. I can see it. 15 is 3% of the total. That is the correct one.
Oh,
15 is 3% of the total. So in translation, 15 is 0.03, I don't know what I was doing, of times X. Okay. You would divide by 0.03, divide by 0.03 on both sides. This then, if you can sort this out, you've got it. 0.03 into 15. This is 2 decimal place shift. This is also 2 decimal places, and it comes up. 3 into 15 is 5, and 2 zeros. X is 500. Do we care? I know what you're thinking. I can read your minds even when I can't see your face. We do care, but that's not what you're thinking. If the total was 500, and we are looking at the 3% defective, I would go 0, I'm multiplying here, and this is 15. 1, 2, 1, 2. 3% of 500 is 15. This works. We are good.
mm.
Now, I did mess that up. And so let's look at the other way. We had 15%. I'm sorry. No, we don't. I need coffee. 3% is 3 over 100. The 15 defective parts actually go here. This is a part because this is defective and this is defective. This here is the total, and that's what we were after. So that's why the 15 belongs on top. It correlates to the 3% defective. This is defective, so is this. This is 100%, this is the total shipment. You then cross multiply. 15 times 100 is 1500. X times 3 is 3x. And in this particular case, I think this one was the winner. 3 into 15 is 500. This is a skill setting this up, but the percent is a piece of cake. Either you have it or you don't, you put it in. The trick is to find out that you get these in the correct order. This is the part. They're not shipping 15 defective parts. They're shipping more. And so the more or the total is down here. And so the 15 belongs there. Once that's set up, this will fly. Right? What do you think?
I like it.
It's pretty good. In this particular case, sometimes I can see ahead which way is best. Other times I need more coffee. But that's the idea. I think if one way works well, that with the translation, use it. Otherwise, this method is good. I can't really see another good method that's most people would like. So it's definitely, I'm gonna.
And for me, it's the English translation, what is